All right. So as Peter mentioned, I am the controls lead, and what I'm pretty much a part of as far as CAD goes and other stuff like that is the pedal box and the steering, so the inboard steering assembly. And so what I'll be showing now as it loads in is the pedal box. And so this is obviously where the driver applies either the brakes or the, in this case, not technically the gas, but more of the, obviously because we're connected to a battery and it's an electric car, but applies the accelerator pedal to then push the car forward. So I'll let you guys take a look at this and just kind of see what we have here. But it's kind of self-explanatory. You have on your right is your accelerator pedal, on the left is your brake pedal, like a normal car. And so with this, me and my team, we've been building this up over this year as well. We continue to develop it every year into what it's been. This right now is really nice. What we have going is we have an adjustable pedal box. So you can see these pedals themselves can be moved from the forward position to the middle position and then to the rear position, as well as with the brakes. And then these will be attached to a floor that then goes in the car. So that's a pretty cool thing that we've done as well. You can kind of see it gets very complex, so you get a lot of hands-on experience with this club. So I'm just going to go ahead and close that up. And then I'm going to open our new assembly. And so how experienced you guys are, but this is the basic window of SolidWorks right here. And so what you have a little bit of some tools as well as some management stuff as far as like SolidWorks goes up here as well. If you hit here, the home button, it pops up. Usually this is the window that loads up. And so you have here, you can go to recent to see all the recent things that you've done. And then there's like alerts and some other introductory like tutorials you can see here. And so with this, what I'm just going to do, I'm going to go ahead and close this. And then in this guy, you can make a new part or assembly. So if we go ahead and hit it, you have a new part, assembly, or drawing. And these are sometimes really good to use if you're creating something new and you're not making it of an existing assembly. And an assembly is just a collection of parts. And so that's all it is you just put it together, and we'll go through that a little bit more. And so now what I'll be doing is I'll be opening the steering assembly. So, all right. And so this is the other kind of assembly that I work on. And as you can see, there'll be a lot of parts, but it's not too crazy. As well, if anyone does have questions, feel free either put it in the chat or you can definitely just feel free to unmute yourself and either ask me to explain what I did again, or I can kind of go over some of the steps that I was taking or whatnot like that. And so that way, no one gets too lost. This is a goal. You want to try to help you learn a little bit CAD. And then if you are interested, you could definitely look at joining the team. And that's where we teach a lot of people. We're all trying to either get a job or progress ourselves as engineers. And so CAD is a good way to kind of do it, gives you good stuff for your resume as well. So with that, what I'll be doing, I'll be going over of how we build a U-joint assembly, as well as I'm modifying this piece right here. And I'll show you how we go about it, which rather instead of creating new parts, what we do, we actually design within our assemblies. And so that way it makes everything a lot smoother and a lot nicer to work with. And so to kind of take a look at this, what a U-joint is you can kind of see it takes the steering wheel, which the steering wheel, I will highlight that for you guys, is that guy right there in blue. And then we have our rack, which is down at the bottom, highlighted in blue as well. And so what this does, obviously, as you turn the steering wheel, it'll then take, go ahead and hide this guy. Go ahead and hide this guy. So it takes this input shaft right here, which is connected to the steering wheel. It goes into this device, and this is called a U-joint. It takes rotation from one input and then it transfers that rotation into the other output shaft. And so the output shaft is here, it's connected to that U-joint, and then connected to what is called the steering rack. And so then what this does is it will move left or right as you turn this, because it has a gearing system. And the gear is called a rack and pinion, and that's where it gets its name. It is a steering rack because of that type of gearing it has. And then it then creates a linear displacement and will move the tires left or right to steer the car in the desired direction. So what we're going to be doing right now is we're going to be changing up this U-joint a little bit into something just a little more different, just because we're going to be transitioning to something else. So with that, what I'm going to do is I'm going to go to new, and I'm going to create a new assembly because I already have these parts already created. And so this way I can show off some of the assembly portions of SolidWorks. All right. And so with this, sometimes it asks you to begin an assembly. And so you can usually go through this and you can kind of insert some stuff as well as possibly create a layout sketch. But that's not what we really go. So I'm just going to go ahead and cancel that. And then now we're going to be left with this really blank template as well. I'll go ahead and show these guys. And how I show these planes is I right click on the plane over here and then hit this little eyeball which says show. So you can see here. And then I have these hidden on mine, so I'll just go ahead and show those. And then you can kind of see we got our X, Y, and Z. These are a little bit different in the SolidWorks that you may have. Our team, we use special text that then calls it the XY, the XZ datum, and the YZ datum. We do it based off this coordinate system. You can kind of see here at the bottom left, and we just do that. It kind of just makes everyone's CAD very centralized. As well, if you want to rotate through different views, what you can do is you can either hit spacebar, and spacebar will pop you up into this little kind of square looking thing. And then say you wanted like a view from up here, you can kind of see in the top right. Oh, here, I'll go with that. So this is an isometric view. Then you have like this, which is not really isometric, but more random. Then you have a right view, a front view, sorry. And then that's the bottom view, I believe. And yeah, so you can go ahead and you can click on those and it'll kind of show you what you're at, and you can see we're on the YZ datum like that. As well, if you hit Control-1, it'll see in the bottom left, we're at front view. Control-2, we're in the back view. Control-3, left view. Control-4, right view. Control-5, top. Control-6, bottom. And Control-7, which is isometric, which gives you that nice kind of 3D view. As well, if you use the middle mouse button, that you can freely rotate around any other part. And sometimes, you might get a little confused. So you can always just hit spacebar and then pop to whatever view you want, as well as just hit Control-1 through 7 to whatever view you kind of wanted. As well, you'll see me zooming in and zooming out a lot. What this is just your scroll wheel. So if you pull towards, you go closer, and then push away, you go farther. As well, if you wanted to zoom on something over on this side, you would instead zoom towards this and put your mouse over there. And so in case you're like, oh no, where'd all my stuff go? As long as you just hit Control-1 or 2, 3, whatever one you want, it'll pop you back to the your main thing. And so with that, what I'm going to do is I'm going to start to build our assembly. And so what we have are all these tabs up top. And so these are going for different things. Right here, assembly, this is the main tab. You can kind of see, if you don't know what each of these buttons do, as long as you just hover over them, you can see insert components as it adds an existing part to subassembly or to the assembly. As well, if you just kind of go along very easily, it shows you kind of what it does. As well, you can always undo what you did. So don't be afraid to just hit random buttons and kind of see what it goes. Yeah, but there's a very good stuff here. And then as well, layout, this is nice for a layout sketch. Sometimes you'll create a layout sketch which gives you an overall kind of view of what you're building, and then you can constrain stuff and stuff like that. Then you have sketch. This is your normal sketch tool. Markup, evaluate. This evaluate tab is very useful in case you need to measure some things. I use this tool a lot. You can then click two different things and it'll measure it between, and then you can do center to center, you can do minimum distance, maximum distance. There's some custom stuff. And so there's a lot of different things that this is useful for. And so you can get some dimensions off of simply CAD. And so that way you don't have to dimension in real life. Or sometimes manufacturers will give you CAD, but they won't actually give you the real part. And so you can then take that CAD, then you can measure it. You can measure, all right, I need 2 inches of space or however long it is. And then from that, you can then make your CAD based off of that, and then obviously manufacture the part, and then it'll have correct dimensions. As well, another good, oh, sorry, I don't mean to click that. Another good one is mass properties. So this tells you the mass of whatever object you're making. And this is always important for us just because you need to know the mass of the car to determine a lot of other things. And so, yeah. So we'll start getting into it a little bit. And all right, so what we're going to do is we're going to start inserting some components. So I'll go ahead and hit that button. Oh, maybe I didn't hit it. Okay, there we go. And so what it can sometimes do, it might pop up some recent parts that you have or other open documents that you have that you might want to input. But in case you don't see it, and obviously we don't want to add this gun because that's our overall assembly, and so that would not be too good. But what we're going to do, we're going to go in, and then we're going to find our parts that we want.
Hey, Daryl, before we get too deep, you want to gauge everyone's experience real quick for the people that are here?
Sure.
Like just see where everyone's at. Sure, I can just go through the list. So Rish, we kind of talked to you already. You're like a beginner with CAD, right?
No, I did the what class is it? ENG 6, I think, or ENG 4, one of the two ENGs.
Oh,
So I
okay.
know how I know how SolidWorks work, but I haven't done it for extremely large assemblies, stuff like that.
Sure, okay. And then Divya, how experienced are you with CAD? You can type in the chat too if you want. Okay, maybe she's not here right now, but let's see. Tucker, how about you?
Say that one more time. Sorry, I had to use the restroom.
No, it's all good. How experienced are you with CAD?
Oh, let's see. I can probably make a square with a hole in it, and that's about it.
Interesting. Okay. So we have a couple different levels of experience. So yeah, Daryl, just to keep that in mind when you're explaining things.
Sounds good. All right. So yeah, so now what we got is I've just got some basic parts. I'm gonna actually go ahead and delete those because I don't need those. I realize now. And then I'm gonna need 2 of these. Okay. So what I just did is I inserted some parts using this insert components tool. And so within ENG4, they do a really good job about how to create parts and stuff like that. And so with that, I'm going to be starting with assemblies. And so assemblies are relatively easy once you kind of get the hang of it, and you kind of you'll really understand it once you kind of do it initially, and then they'll start to make a lot of sense. As well, they can sometimes be a little bit tricky, especially when they get larger. But I will go into some more CAD based practices as far as making parts themselves in a little bit later. But as of right now, I'm going to be using some assembly work, and so that way I can show you guys how we do stuff here. And so within, I just used the insert components, and then I hit that browse button, and then I inserted the components that I needed. And you can kind of see this does not look like what I showed you before, and that's totally fine. I'm gonna kind of change it up and do some stuff. So I'm gonna go ahead and hit this cancel button. And then now we can see, I'll go ahead and open this guy up for you guys, and then we'll zoom in right here. So you can see we have 2 parts total. So we have this guy, and then we have this one. And so what this is, we're gonna be constructing is a single U-joint And so what I'm going to need 2 of these and then 1 of these. So we already have 1 of those. That's perfect. And then what I'm going to do here, I'm just going to select it, then hit Control C and then Control V, and it'll pop it right where my mouse is. And you can kind of see I can then move these guys around. They're not constrained anywhere except for this one. This one is fixed. And so what I'm just going to do, I'm going to go ahead and close it. And I'm just going to make this a little bit nicer. I'm going to go ahead, drag this, move it below. So that way I got my 2 bodies and then my block, which is this center thing right here. And now what we can see, so we have this F right here. So we have this F and then we have this little dashed line. These are very helpful. So what F is, F means it's fixed. So it basically, we can see the origin is right here. So the origin of our assembly is right over here as well. You can kind of see these are where our planes kind of intersect, is right along that origin. Here, I'll go and show our origin here as well. Should be able to, there we go. Oh, that didn't work. Okay, that's okay. So yeah, so our origin's right here. We can kind of see that's where all of our planes intersect, but that's not too good for us because we want the origin to be in the center of this guy. So what I'm going to do is I'm going to right click on our first one and it pops up this very big window. This is very nice because there's a lot of hot buttons here. So you can kind of see we can open this part. So if I go ahead and hit open, say this part wasn't up to spec, or I measured some different things and it was just a little bit different. And it should open. My computer is thinking. Okay. There we go. So say it was not up to spec and I just needed to change a couple things, I could possibly change it, and then I could go ahead and I'm obviously going to save changes, yes, and go back, and then it would auto update as well. Another nice thing, if we go ahead and right click again, you can kind of see open part in position. So say if it was, you wanted to edit this part in the position it was in, you could do that. Or open drawing, if I wanted to create a drawing to this, or if there was a drawing already attached to it, I could open up that. And so say if I was manufacturing this and I wanted to see the drawing of it that someone created, I could just do that really easily as well. Another big one is edit part. So this one's really nice. Okay, I'm just gonna, it's gonna prompt me to save this. So I'm just gonna save this. Right. So that was just me saving the document. I gave it a name, and you can see now I updated the name right there. So yeah, but that's not what we're explaining. But now you can kind of see in this top right, we now have this button that appeared, and this just tells us that we're editing the part currently as well. You can also see it turned blue here. So this means we're also editing the part. So what we have is we have a basic we have some sketches and some features that we've done to create this part, which I'll show off later. But just know that we can edit the part from in here, and from there we can make changes, and then it would actually update within the assembly. So that's pretty nice to do. So I'll go ahead and exit out of that. But now what I'm going to show is we're going to hit this button here, float. So what float does is it basically unconstrains it. So first this component was fixed. Now we can see we can drag it around, we can put it wherever we want. And so now, depending on where we want it, we can do that. So in an assembly, we inserted our components. Now we can go over to this button, mate, and then it creates geometric relationships between components to define allowable directions of linear or rotation. So what that means is when you go to move component, if you just hit that little drop down, you can see you have move or rotate. So as of right now, I know these parts, I haven't done anything, and so I know they're just floating, and so I can rotate them. And so this, you might want some rotation. Say if you want to see a part rotate and you want it to have the ability to do that, you might want that. And so you might not want to constrain it fully. But normally you want a fully constrained assembly just because it's relatively good to always fully constrain your things. And so with that, this little dash mark means it's not fully constrained. It means that it can rotate and it can move stuff like that. So what we're gonna go ahead and do is, since I know I want this guy on my origin, because this is the center of my kind of assembly, what I'm gonna do, I'm gonna select the origin here, then I'm gonna go ahead and hit mate. And then what I'm gonna do is I'm gonna mate this to the origin of my assembly. So now you can see we've moved, that origin is right along that origin. And sometimes you might not want to align axes. You might just want to align the origin itself, but maybe you might have it skew. But in our case, we're going to align those axes because that is what we want. So I'm going to go ahead and hit OK there, and then just hit this check mark to get me out of the mate window. Now you can see that dashed little line right there is now gone. And what we can now see is as we move this, it says the selected component is fully defined. It cannot be moved. And so that's perfect. That's what we want. That's what we're looking for. And so I'm going to go ahead and close that window over there. Now you can see this part is good, but this other one, we can see we're going to want them like right about here. And then I'll need to rotate that and some other things like that. This is a lot closer as well. We can see under mate, we now have the mate that we added, which is a coincident mate between the Borgeson DU joint block, which is this guy, and the origin. So that's good. And now what we're going to do is we're going to add some more. So what I'm first going to do is we're going to go into mate. And, oh, sorry, I did not explain all the mates. My bad. What you have is you have standard mates here. So you have your coincident, which means something touches another thing. So say you wanted the inside wall to touch right here. Granted, you can kind of see, oh, I kind of messed that up. Sorry about that. So say you just did what I did, you messed up, you click something that you didn't mean to click. What you can do is you can either right click and you can clear all the selections, or if you just wanted to say, oh, I want to select something else, you can hit delete and you still have that one face selected. And then now we can select this face that I was going for. And so you can see now it's coincident. So if I wanted this mate, I would hit OK and then hit check mark again. And now what we can see is with that, if I tried to rotate this component now, so say you went like this and we rotated it, we can only rotate it along this axis because this face that we mated, so I'll go ahead and hit check. The face that I mated, which was this one, is geometrically constrained to always be touching this face, which you can see it is right there. But that's what I want. So what we can do is we'll just right click this guy and we'll go ahead and hit delete and then yes. So now we can see it's back to being unconstrained. So yeah. So now what I'll do is I'll go back into the mate. So that is coincident. Now we have parallel. So say you wanted to make this, I find is pretty good. What you can do is you can open up these folders or this drop down menu right here, and then we can kind of select the different planes of each part itself, and then you can make those coincident to either other planes, to other things, or you can make them parallel or different things like that. And so with that, what I'm going to do is we're going to click this guy, and we can see that's the XY datum of that. Now I'm just going to move. Yeah, I'm just going to move this real quick so I can get access to that. I'll move you guys back down. And what I'm going to do, I'm going to make these XY data. And so normally it'll snap to whatever we use. As you can see right here, I'm using coincident, or well, I'm not, but SolidWorks tells me coincident should work. And you can kind of see these two planes are touching each other. And so that should work. I could also use parallel in this case. And as you can see, what that does is it doesn't necessarily line it up, but instead it just makes both these planes parallel to each other. As well, to perpendicular, very similar thing. It literally makes them perpendicular. So now you can see they're kind of standing up. And then if you have lock, so you have lock components together, what this does is it'll set whatever angle this was at relative to this other plane. it'll lock that angle in and it'll always keep that information. We don't necessarily want that. So we're gonna hit X on that. Thanks. And then we're out of that. Oops. And so we'll go back into mate because I accidentally exited out because I didn't want the lock. Another thing you can do is you can also do tangent. So if you select a circular object, which is that, and then a flat object, like here, you can kind of see, it's a little bit hard to see that, but it's tangent right there. So it's resting on that outside face. Sometimes that's useful. Other times it's not so much. But yeah, that is a good one. So that creates a circular face and a flat face. It gives them a geometric relation there. So then we'll go ahead and clear all those selections. Another one is concentric. So it takes, so we're actually going to select that concentric. It takes two circles and it puts them right in between each other. So you can kind of see these pieces are aligned through that through that axle right there. If you kind of drew, sorry, axis, my bad. The axis, if you drew that right along the center through that, they're lined up on that axis because you have those two circles going into each other. So yeah, so that's pretty nice. And then the last couple ones, so we have this distance one. So if you hit distance, so you can kind of see what this does is it'll create like a little circle. So technically this will be our radius. As well, you can kind of see there's different things. So if we did a center to center distance, and then we set this to, you can put this at whatever distance you would like. So say you wanted half an inch. So if we did 0.5 inches, you could see that is half an inch away from the center. You could also do like custom. You could do minimum distance is half an inch. You can choose a lot of different things to get that specific geometric constraint that you want. But in this case, I'm going to go for concentric because I want it lined up on that axis right there. So what we'll do is we'll go ahead and hit check mark there. And then the last thing is we have an angle. So say you wanted, we'll go ahead and select the planes again. So we'll select the XY and the XY for this guy. Say you wanted to add an angle. Say, all right, I want it at 30 degrees. So we'll go ahead and hit 30 and hit enter. And we can see now it aligns it at 30 degrees between those planes. And so that might be useful. You can also kind of, if you hit flip dimension, you can kind of see it flips it the other way. So that might be useful. As well, this does require a reference entity. So I would probably choose, I think I have to choose a, oh, oops. Yeah, you just have to make sure you choose a reference. Oh, actually, you don't. Yeah, okay, cool. So we'll go ahead and check mark those, and then we'll check mark again to get out of everything. And then as well, I'm just gonna hide these planes because they are kind of in the way. And so what I did, I use this eyeball, and this can view planes or unview planes as well. If you just hit view planes and you see these, but you don't want to see them, you can just go over here, right click, and then hit hide. And so I'll just go and do that for all the planes. And it's always good. You always want to hide your sketches. You can also see here, this sketch right here. If we were to go ahead and show it, you can kind of see how everything would get kind of cluttered. So it's always good to hide your sketches if you don't need them for like referencing or anything like that. So I'm going to go right click on it and then just hit that eyeball, hide, and it'll do that. As well, you also saw when I do show it for this part, so under this part, since these, oops, click that. There we go. Since these two parts are the same, when I did show the sketch on one, it actually already updated the other one. So that's a nice feature. It can also cause you a little bit of, it can be a little bit difficult just because say you wanted to make this part different from this one. Well, you need to make two separate parts. So you just got to be conscious of that. So yeah, so with that, we can go down all the way down. We'll go ahead and close these guys up to make it less cluttered. As well, we'll go ahead and hide that sketch as well to reduce clutter. We can see we got our one mate and then our second mate and then this angle. I don't want this angle, so I'm going to go ahead and delete that guy. And then I'm going to go back to our mate and I'm going to create a parallel reference between this guy, the XY, and the XY. I'm going to go ahead and create parallel. There we go. Check. And then as well, sometimes a very nice feature is the symmetric mate, or there's some other ones in the advanced mates. So these standard mates, you have what I just listed. They're obviously relatively standard. They kind of make sense. So now what we're going to do is we're going to go into advanced mates. So here we have profile center. So you might want the center of something to align with the center of another thing. So this one I don't use too often, but you can do that. And then you can add a dimension. Obviously 0 inches will have them be touching, but you could also add like a custom offset to whatever distance you would like. Symmetric, this one's pretty nice. What this does is it'll take two different things. So you could take, we could do like this face and this face right here, and then we could choose the plane which it needs to be centered around. And so we could do it that way and make it obviously nice and symmetric and in the middle. As well, another one is width. So I like to use width a lot because I can take these two faces, as well as in these tab selections, I can then select this one and this one. And what you just saw is it moved all that to be centered between these. As well, what you can do is on this, you see how it has different constraints. Depending on how many things you select, you could either add it over to the right or there's sometimes some other options, but I use this for centering things a lot. And so you can kind of see now everything's looking really nice and centered. As well, oops, scroll too much. Sometimes we'll go ahead and hit check mark because I want this guy. So we'll hit check. All right, then we'll go back into the mate so I can show you guys some other things. In the advanced mate, you can see path mate. So possibly if it travels along a path and you want it to mate it to that path, you can use that. I've never actually used path mate before, as well as this linear coupler. But you know, if you obviously need those, you can do that. As well, limit distance. So this, if you wanted to have your part be flexible, which this will be, and you wanted something to move, but you only wanted it to move a certain distance, and you needed it to stay, it can only be within 1 inch. So you could definitely hit that, and that way it'll allow it to move, but it'll only come, once it hits that 1 inch radius, it won't move any closer. So you can do that. As well, there's a similar thing to limit angle. So we're actually going to be using this, where it actually limits the angle of this part to only be a certain amount. So that's those advanced mates. Then you have mechanical mates. So these are sometimes nice. If you have a cam, which is like a little lobe kind of thing that rolls around, and you need that, you can do that and it'll create that movement. As well, if you have a slot, so if it moves within a slot, you can assign that mate. Hinge, pretty self-explanatory. If it moves on a hinge, you can do that. Then you have a gear. So obviously as you turn one, it'll turn the other one. That's kind of a gear mate. And then rack and pinion mate. So as you turn something, it will then create a linear distance movement on another thing. A screw, I've never used a screw mate, so I'm not exactly sure what's there. As well, universal joint mate, I've never used that there as well, but that does something if you ever need it. And these mechanical mates, these ones are very nice, more for your motion study. So what you can do is you can have a motion study. And so for example, in the steering system, you could create a motion study to where if you rotate the steering wheel, this will then cause a movement between the rack, which you might want to see, as well as should be relatively interesting. All right, so that kind of goes through all the mates. So I'm just going to hit check mark to get out of that. And then as well, what we have in this bottom window, we might have different setups. So you might be doing some different things as well. You can kind of see there's like model, 3D views, and motion study. So if you just hit that model, it just brings you back to the main window. And that's what we mostly use to obviously look at all of the modeling stuff as far as this. So yeah, so now since we added all of these mates, these guys right here, you can now see that dashed line that we have for this one is now gone. And we can see when we try to move it around, it doesn't move. So that's perfect because we don't want this to move. So yeah, so now what I'm going to do, hit mate, and we're going to go through this other one. So I'm going to go ahead and hit a concentric mate. And so sometimes you might see that this is lined up like this, but you might not necessarily want that. And so what we can see is we have mate alignment. So if I go ahead and hit it, you can kind of see it flips it around. So in this case, it's not necessarily what I want. So I'm going to go ahead and keep it like this. Boom, boom. And then I'm going to go ahead and hit the check mark there. And then now we can see it's starting to look a little bit more like what we want. So yeah. And there we go. You can kind of see we have a little bit of movement, but we still see it goes up and down. So with that, I'm just going to kind of drag it down here just to give myself better access. And then what we're going to do is we're going to do a similar advanced mate, and we're going to use that width that I used. And so we're going to go ahead and select this guy. So those interfaces, because I want those interfaces to be centered between the outer faces here. And so there we go. Now it's centered. And so when we hit check, we kind of see we have now this thing that can move like that. And that's the only movement we have here. And so obviously we can't have something like this or like that. And so what I'm going to do is I'm going to take, and this is where we'll use that limit angle. So limit angle, I'm going to use 30 degree, or I'm going to use actually, yeah, we're just going to, we're going to keep it like that actually. And then I'm going to take the XZ and the, oops, I want this one. And the XY, oops. Okay. And so what I'm going to actually do is I want 180 plus this. So maximum, minimum. Yeah, so we want we want 150, and then our maximum to be 180, 210. All right, here we go. I only want 15 degrees on both sides. So what I'm going to do is obviously I want these on the opposite side. So that's 180 degrees. And then if I subtract 15 from 180, I will get 165 if I did that correctly. And then on the other side, actually, no, I lied. Sorry. I want 30 degrees. So yeah, so 180 minus 30 is 150. And then for our maximum, we want 180 plus 30. So there we go. And so what we can then do is we'll hit check mark there and then check mark again. And what we can see now, the nice part about that limit angle is this will actually have some movement on it, but what we can see is all of this is defined. So now SolidWorks knows that it's all defined and it only can move within this angle, which is super cool. So yeah, so that is how a little bit on more the advanced side as far as assemblies, but I hope that gave a good overview there. And so with that, we now have this really cool part that works and it has some movement on it, which might be a little bit different, as well as you can implement that into a lot of different things using either the advanced mates, which gives you that distance, or the limit angle in this case. And so yeah, so I'm going to go ahead and just hit save and then save all. And there we go. And so now we have a working assembly like this, and it looks really nice. And yeah, so as far as like the assemblies go, do we have any questions there? Did I go through anything too fast? I might have, and that's okay. Also open up the chat. Oh, I cannot see the chat. Rip.
Yeah,
All
Tucker asked a question in the chat. How come you don't use rack and pinion for the steering column or for the steering wheel?
It's very difficult to use. And it's one of those things where sometimes it's a little bit hard to do. Not hard, but rather SolidWorks does have a little bit of a hard time kind of with moving parts. And so we just try to limit the amount of moving parts as much as possible. What SolidWorks define moving parts is as flexible parts, which makes sense. You have fixed parts and flexible parts. And so the more flexible parts you have, the harder it is for SolidWorks to kind of keep up, as well as none of these flexible parts break. So either you have really good CAD, as well as sometimes SolidWorks needs to work properly, which not all the time does it work properly. And so it makes it really hard to have a lot of flexible parts and make sure everything works the way it needs to. And so with that, our team has been looking at other softwares such as Siemens NX, and that one, it has a lot better engine. And so it takes those, is able to use those flexible parts, and it kind of, I don't know exactly what it does, but it computes them better, as well. It kind of auto updates itself a lot better. And so you're actually able to create moving parts in that software a lot easier than SolidWorks. And so that's the main reason why we don't use it there, just because it is a little bit difficult to use and keep everything looking nice and not breaking.
Thanks, Daryl.
You're welcome, Tucker. All right. So I'm gonna jump on over into our other assembly. And so I'll go ahead and close this guy up. And so now I'm going to show. So I'm just hitting show on all this stuff, so that way you can kind of see the full assembly. And then, so what I'm going to be doing is I'm first going to be removing this part. So I'm going to go ahead and suppress this. And there we go. We can kind of see it is suppressed. As well. There we go. We're going to go ahead and suppress this guy as well. And suppress that. Okay, perfect. And so what this is, you can kind of see I deleted a lot of stuff, but that's okay. We're going to be changing it up within this seminar. All right, so what we're going to be doing is, I'm going to be showing you a sketch, and I'm going to show you the sketch. So what we can see, if we hit Control 3, so if we hit Control 3, we get a nice side view. And so what this is, we see we have 2 lines, or I guess 4 lines, or no, 3 lines, count, wow. So we have a line there, a line here, and a line here. And so what we can see is our rack will actually be positioned around this line right here. So, under mates. I don't want to about this. Okay. Sorry about this one. Okay. Sorry about that. I just want to make sure I can do this relatively quickly. Slide. All right, now let's. All right. No, it's not letting me. Okay, that is okay. She won't do that. Okay. So this was working a lot better than my head. That's okay. Let's press that. All right. All right. There we go. So what we're gonna do, we're gonna insert components, and then it'll pop up this window, and then we're gonna find where we just made our new part that we just made. There we go, found it. And we can see we're gonna put it in like that. Boom. All right, now it's in, and you can see all the way at the bottom, we have the part that we just made, and you can kind of see it's all fixed within here. So what I'm gonna do real quick is I'm gonna make it flexible. So this gives it the ability to move, like I just mentioned, and it's right here, make subassembly flexible. So we'll go ahead and do that. And now you can kind of see, oh, I don't have it constrained very much, so you can't see the movement that it gets. So what I'm gonna do, I'm gonna take this guy, take this guy, boom, 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 yeah, and then, all right. All right, so now you can kind of see, if I go ahead and hit check mark there. So I just added a couple mates, and so now you can kind of see it's almost in the assembly where it'll be. And then we can kind of see it still rotates. So it has that rotation. As well, we can kind of see it is able to bend a little bit. But obviously the rotation is kind of messing us up there. So I'm gonna go here. And so the nice part about mates is what you can do is you can click here and you can see we have edit feature, suppress, as well replace mate entities. So say you are replacing a component, you can then hit replace mate entities and you can change it that way. As well, you can also hit zoom to selection. So it'll kind of, in this case, I was too zoomed in, so it zoomed out, but you can see what you selected. But what I'm going to do is I'm going to hit edit feature. And so this just allows us to either change what we want. So I'm going to change it to concentric. And then as well, I'm going to hit lock rotation. And so that just locks the rotation in. So that way I can show you guys this. And so see, now what we can do is we can take this guy and you can kind of see it moves because we have that limit angle on there, which is super nice. So yeah, so what I'm going to do now is I'm going to right click. And the nice part, if I wanted to unlock the rotation, I could go back into edit feature and go through all that. As well, there is a button right here, unlock rotation. So I'm just going to go ahead and hit that. As well, you can see we have flip mate alignment. So say if I hit flip mate alignment, you'll see it rotates or it swivels around. So that might be a useful feature in case something's not lining up like you would like. You can go ahead and rotate that around, but I'm just going to go ahead and flip it one more time. There we go. And so now we got it flipped, it's lining up with everything, but it's not exactly where we want it just yet. So I'm going to go ahead and take this guy and take go ahead and hit mate. Then you just kind of got to look at the parts you have, and then make sure you line it up correctly. So we're actually going to take, where are you? We're going to take that guy, and then, yeah, that looks good. I'm going to go ahead and check mark. And now what we can see is, we can see how it rotates on that, like that, which is kind of what we want, but also not what we want, because if I hit Control-3, we can see I want it to bend along this line right here. And so what I'm going to do is, instead of, we're going to go all the way down to our mates, we can see we just applied that one. I'm going to go ahead and edit this guy and realize that I don't want the XY, so I'm going to go ahead and delete that one. And instead, I'm going to take RXZ, and that should rotate some stuff. All right, check. And then we'll hit check mark again. There we go. And now we can see we have it and it rotates like that. And so we can get it to rotate in whatever angle we would like as far as it goes. And as well, the nice part is on the manufacturing, on the manufacturer's website, it was limited to 30 degrees of bend. And so that's obviously why I set it to 30 degrees. So you can see it goes up 30 degrees or down 30 degrees. And so we kind of have that line running through, which doesn't look to be 30 degrees like that much, but it's relatively close. And so, yeah, so that is kind of how we put it into the big assembly. And so I'll go ahead and hide this front sketch just because it's a little in the way. So yeah, so now we can see that. And since we don't have, hasn't been updated just yet, there's a lot more work that needs to go in to mate these parts up and kind of get everything fitted. What I am going to show though is right here. I'm going to be CADing. We'll go ahead and show our upper column as well. Where are you? So we can see this column, it gets supported by this bearing, and then gets attached to, this is a bar that goes across, and we can see the pattern of that bar if we reference. We can see, so this bar is a part of the car, and so that's how this upper portion gets attached to what this is called is the front roll hoop. It gets attached there and it gets welded. So what I'm going to be showing here is how we go about creating parts within assemblies, which in itself is already a good skill to have. So first, I'm just going to go ahead, I'm going to hide this sketch here just so it makes things a little bit easier. And then what I'm going to do now is, instead of insert components, what a nice part is you can do is hit that drop down right there, and then you can create a new part assembly, or you could copy a part with mates because it might be, you might be adding in a lot of screws or stuff. And so you just want to kind of copy and paste and make it a little bit easier for yourself. But the nice part is we can add new parts and assemblies within this assembly and then design it off there. So what I'm going to do is I'm going to hit a new part. And then you just got to hit check mark. It'll drop it in somewhere. And then we can see, I'm going to go ahead and close up all this stuff. So it's really easy to see. All right. So now, all right. So now we can see down here at the bottom, we have our F, which means fixed. And here, I'll go ahead and open this guy up. We can see we got our origin is exactly where the origin of the assembly is. So you can see there's no difference because it's right there. And then we got our X, Y, Z, and the origin all right there with this part that we inserted. And now it's just kind of a regular part. So what I'm going to do is you can actually no. So what we're going to do is we're going to make it float again. So float just allows this part to kind of be moved around. And what I'm first going to do is before we even start to design the part, I'm going to go ahead and move the origin of the part where I want it. And so with that, I know I'm making a connecting piece that connects this and our, I know I'm connecting these two highlighted pieces together. And so with that, I would like the origin to be right in the center right here. And so it's always key to know where your origin is. If I just started designing and just started creating sketches and other things like that, soon my origin of my new part would be way down here when the part is already way up here. And so that doesn't really make sense. That makes the origin really random. And so what I like to do is create a meaningful origin. And so if the origin is right in the center of where I want it to attach, that would be perfect. So what I'm going to do is I'll go ahead and select our origin, and then I'll go ahead and hit mate. So I've selected the origin. We can see the origin of that part. And then what I'm going to do, I'm going to hit that bar, and we can see now our origin is kind of at the edge of that bar. That's because we have that coincident mate. So instead, if I do concentric, what it does, it plops it right in the middle. You can kind of see that with our highlighted things, and that's looking really nice. So we'll go ahead and hit that for check. And then I'll go ahead and hit check mark, so that way I can select some more things. So now we can see we have X, Y, X, Z, and Y, Z. So now what I'm going to do is I'm going to place it right in between these two guys right here. So I'll go ahead and hit mate. And then this is where we're going to use a symmetric mate. So we'll go ahead and hit symmetric. And then no. So what I'm going to do, I'm going to hit this guy, oops, and rotate it around and hit this guy. Sorry about that. My selections were kind of bad. Oh, oops, that messed things up. Okay, so we're gonna hit X. So I kind of messed up there, but that's okay. I just hit X to kind of cancel out of everything, so that way nothing broke. And I'm just gonna go back into the mates, and we're gonna go all the way down to the bottom. We're gonna select that same plane, and instead this time, I'm gonna use width, just because that will work. And so now we have the plane selected. Now I'm going to go to tab selections. So I'll hit that face and this face. And then we'll go ahead and make it centered. And I think that should work. Oh, that did not. Oh, man. Okay. That is okay. Let's go ahead. All right, so what I'm going to do, I'm just going to clean up some of these mates that I broke. I'm gonna select that guy, check mark there, check mark. Now I'm gonna go into 8. So now I believe the symmetric make will now work. We'll go ahead. There we go. Okay, now we can see we got that plane right in the middle. So I'll go ahead and hit check mark there and then check mark one more time. And now if I hit the origin of this part, we can see it's right in the middle, but we still have it unconstrained. It's still like that. So the last one I'm going to do is I'm going to take our YZ and then I'm going to go ahead and hit, or sorry, XY, my bad. I'm going to hit XY, then I'm going to scroll up to the big thing on top. And we can see if I hit XY there, you can see how those are parallel. So I'm going to go ahead and hit check and then check one more time. And now we see the part is fully constrained. So even though I haven't even made anything, like I haven't made a single sketch, single feature, single anything, I already have a fully constrained part. This promotes good origin placement because now I have my origin exactly where I want it. I have my my reference planes, which are these 3 planes. I have exactly where I want those, and I have it already placed within my assembly without even creating any part or anything like that. So yeah, so now what we're going to do is we're going to start actually making the part. And so what this consists of is it's going to be a little sleeve that goes over here, and then we're going to have tubes that then connect up onto this main part right here. And we'll be using some different sketches and other things to kind of create that. All right, so first off, what we're going to do, we're going to go down to our part, and what we're going to do is we're going to right click and we're going to hit edit part. So now we're editing this. It's always good to see this in the top right corner to know that we're actually editing the part within the assembly. If you hit that, stuff that you make will be actually done in the whole assembly and not as a part. So if you tried to export the part, you would get nothing. And so it's always good, excuse me, to edit the part. That way you just make sure everything is all good there. So yeah, so within this, how to create parts in different things. What you have is you have features. So my SolidWorks might look a little different to yours. You might not have as many tabs here. And so these tabs are really nice because there's a lot of different things you can do within SolidWorks. And so if you find a tab here that you want to explore, or you just want to learn what SolidWorks has, you right click any random tab. So if you right click, you go under tabs, you can see there's a ton of different things. So there's sketch, sketch ink. Sketch ink lets you like draw a little bit, look a little like Microsoft Paint, structure system, mesh modeling, all this other stuff. I have most things selected, but again, I don't even have all of them selected because I haven't used them. But sometimes there might come a time where you're like, oh, where is that button? And you might just need another tab to open it because you don't have the tab. And so there's a lot of different ones, but I just recommend you can select all of them, but then again, it does get cluttered. So I kind of select the ones that you need, and you can always add them in whenever. So yeah, so with that, we'll go over these different tabs. So features, this is where you have your basic features that kind of do mostly what you need as far as creating parts. So with this, extruded boss base, so your regular extrusion, revolve, makes sense. It revolves a part around an axis as well. The really nice part about SolidWorks is it does give you all of these tips, and you can kind of see it, have a live demonstration there to see what it gets done. Swept boss base, this is also nice. So it kind of creates a profile along one thing. And then you have lofted, boundary boss, and you have a lot of these other ones. So basically all of these in this box right here are additive. So it adds material or adds something. Then you have these guys right here, which are subtractive. So these are all your cuts. So instead of an extrusion, you could draw a circle and then hit extruded cut, and you could then cut a hole. Or also there's hole wizard. Those are sometimes nice for different size bolts and other things. Revolved cut, swept cut, all these different kind of cuts. Then what you have here, this is kind of like your different kind of, they're a little more niche. What you have is fillet or fillet. I think it's fillet, but I guess you could say it whatever way you want. This rounds the corner off of stuff. So that way, if you don't want a hard edge or you need to create a radius on a corner, you can just do that really easily here. And so that's useful. Linear pattern. So you can kind of see if you wanted to create a hole 15 times, but you didn't want to draw 15 holes. This is sometimes nice, or it also has, I don't know if I can click the drop down, I can't. It also has a circular pattern. So say you wanted a hole that's spaced out 60 degrees between a point. And so that is what I've used in here. So you can kind of see I have one hole, or I have a hole here, and then I rotated it every 360 degrees divided by 3, which is 120 degrees. So I rotated 130 instead of making each hole by itself. So that's pretty nice. As well, rib, you can kind of see if you need that. That's there. Draft, this is sometimes nice with other composite stuff that we use. This draft is nice as well. Yeah, it just does a little bit different things. Shell, hollows out a part. These are all very nice tools. They don't get used very often, but sometimes you might need to do this. And so this is a good place to do it. Another one, reference geometry. This is very nice. So we have plane, axis, coordinate system, point, and then mate reference. I haven't ever used a mate reference, but most of these, so say I needed a plane, or I wanted to sketch on a plane that was off axis. So what I could do is I could hit plane, and then what I can now do, since we're within this part, I kind of want to be operating within here, but say I wanted a plane that was 5 inches away from this plane. So what I could do is I can hit this guy, which means this is our first reference. And then now I can go within this offset distance and then hit 5 and IN for inches. And then we can click out of it, and we can see now it has a plane that's 5 inches. And say I wanted 2 planes, 3 planes, or you could get a lot of planes depending on what you want. And so you might be doing what's called a loft. And a loft takes a profile, and then you link it to another profile, another profile, another profile, and then it kind of flows it all in between. And so you might use this where you have a plane 5 inches away or whatever distance away. As well, you can also say you didn't want it this way. You could do, oh, I want it this way. Or say you wanted to do, say we did like 2 planes and you did mid plane. Oh, that doesn't work. But yeah, so that offset distance works. You can do that. As well, you have an angle. So what you can see here is when it gives you like some messages and stuff like this, you need to select more references in order to get this angle correctly. But say you wanted, I think I can select this. Yeah, so it also tells you when the current things are not correct. So I can't select this just yet because I need to have a line that it's based off of. So yeah, so I can't do an angle just now, but you can do a lot of different things. So say you wanted it perpendicular or parallel to a different thing or something else like that, or distance, as I said, you can always do that. And there's a lot of different things for the reference geometry. And the reason why you might need this is say you wanted to create all of these features right here work off of sketches. And a sketch, you have to sketch on a plane. So if I wanted to sketch on this plane, I would hit this plane first, and then I would hit sketch. And now I'm kind of sketching on this plane, and you can see all these different things pop up. And so with that, say you didn't want to sketch on one of these 3 planes, that's where this reference geometry would come in. And so you would then, I'm going to go ahead and exit out of the sketch, script changes. And so that's where this plane would come into effect. Say you wanted to create a sketch on a plane above, you could then do that. As well, sometimes you might want to create an axis or a coordinate system or point or other things like that that help later down the line for other things where you need that. And so definitely if you join the club, you'll have a lot of experiences of why you might need this other references, but that's a little bit too much for now. And this curve, it also is a little bit nice as well. You might find a lot of bolts have this helix and spiral, obviously, because that creates like the bolt threading. And so that uses that. And yeah, so that's pretty much a lot of the features. There is another tab called surfaces. This surface tab is basically the same as the features tab, but instead it's all for surfaces. So you have extruded surface, revolved surface, swept surface, blah, 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 the list goes on. This is nice if you're using a very thin material and you want to use only a surface which doesn't really have mass or a thickness, but instead it's really flat, and you can use it that way. As well, you can then thicken it at the end. So it all depends on that, as well as sometimes, oh my gosh, excuse me, it gives you a little bit more freedom sometimes, or say the extrusion is not working for you the way it needs, maybe a surface might work out for you a little bit better. But yeah, as well as there's a lot of different other tools, but yes. So what I'm going to be doing is I'm going to go to XZ data, and then what I'm going to do is I'm going to create a revolve right around this lip right here. So what I'm going to do is I'm going to either select, you can select this plane or this plane, doesn't really matter. I'm just going to choose this one just because, yeah, that'll work for me. I'm going to go ahead and hit Control-3. And then now what I'm going to do is I'm going to create a box. So create a little box like that. Very random. There's no really rhyme or reason why I put it there. And then what I like to do is I like to just kind of draw random things, and then I will constrain it myself. And what I try to do is add as little dimensions as possible. So obviously you can kind of see here when you drag it around and like this, it can really do anything you want as well. Oh, you can't drag that point. But yeah, but you can kind of do that as well. You see these little green marks. So I'll go ahead and show those. So those are called sketch relations. So if I hit view sketch relations, which is just under this eyeball right here, this is kind of your visibility window. So you can view different things. And sketch relations is one of them. You can also turn it off because sometimes it'll get very confusing. But you can kind of see I got it'll show me. Oh, yeah, there you go. So horizontal 3. So if I go ahead and click it, it highlights this in pink, and that just shows me that this line is horizontal, which is exactly what I want. So yeah, as well in this, you have line, circle, you have your different drawing tools right here. Trim entities is really nice. What I find, I use this a lot. So if I go to trim entities, and then there's power trim. This is nice because you can kind of just draw around and go like that and cut stuff off if you like. As well, what I find trim to closest is pretty nice. If you just click and then it'll trim it to the closest thing like that. So I'll go ahead and just delete everything. Yeah, and then as well, convert entities is nice. So say I was drawing and I want to have this circle pop up onto my sketch. I could hit check mark, and you can see here it created a line like that. So now I have a line here that I didn't even make, but it's already defined off of this surface right here. So that can be very useful for some different things. Offset entities. So say, we'll go ahead and hit X. So say I drew a box and I had my box where I wanted it, and then I hit offset entities. Now I can either, if I reverse it, I can do a box inside a box. And what this does is it's really nice because it makes things a lot easier if you're just doing an offset. It'll automatically define everything as well. If you have a complex curve, it'll kind of already do everything for you, so you don't have to design a lot of things, and you can just make it like that. So I'm just gonna hit close because I don't really want to do that. Now, a good note of thumb is you always want to have things constrained. So I'm gonna go ahead and just select my origin, then hit Smart Dimension. Oops. Mess that up. There we go. So now what we saw there is this line turned black. And so what you always want to do, you always want to have everything that you make turn black. At least that's what I've seen. Some people, it doesn't really matter. and I've heard from some industries that they don't really define everything. While that can be okay, I've always found defining every single thing is always better. It's always easier to follow and stuff like that. And so with that, you always just want to make sure everything is constrained. And so what we can see now is as I try to drag around this line, it doesn't really move. And so that's always good. So yeah, so that's just adding what I called a smart dimension, which is right here up at the top. If you hit it down, you can kind of see there's other different things, but I normally just use smart dimension because it'll automatically snap to what I like to do. So yeah, so I'm going to go ahead and delete that dimension. And instead, what I'm going to do is I'm going to go here. I'm going to select, I'm going to select this little edge right here and select this point. And what I did, I just held shift. So if you hold shift click, if you like shift click, what you can do is you actually select two things. And so then what I'm also going to do is I'm going to select that. Oops. Oh, it's not letting me do that. Why is it not going down? Okay. Ah. But yeah, so yeah, so that's how you constrain different things and stuff like that. So what I will do is go like that, and then there we go. Okay, yeah, so what I just did there, you can kind of see, it's a little bit hard to tell, but I'll go ahead and highlight these guys for you. So I just highlighted it by, again, holding shift click, and I was able to highlight it. Now, if we hit Control-3, which is our side view, and I scroll in here, you can see it aligns perfectly with this bearing right here. And so that's just a really nice way to dimension things very quickly without adding any dimensions. So I'll go ahead and select that edge right there. If I can select it, it's a little dark to see, and then shift click this point, and we can see this little window pops up right here, which you can really quickly make some constraints, some sketch relations as they call. I also call them constraints. So I'll be using that word interchangeably. But you can select different things like that as well. On the left, it also has the same three things. So I'm just going to go ahead and hit pierce. And so now we can see our sketch is almost defined except for this guy right here. And so what I'm going to do is I'm going to take this line and this line right here. I'm going to go ahead and hit pierce like that. And now we got a fully defined sketch with just a couple things. And if you also notice, you can also create a rectangle with only, oops. If I go ahead and delete this relation, it actually stays fully defined. So you only need two references, that bottom corner and top corner, and you can fully define a rectangle. Yeah, so the next thing I'm going to do, I'm going to create this random line way up here, and that'll work. And so with this line, I'm going to create an axis in between this two right here. So I'm going to go ahead and select my origin and then shift click and select this guy right here. And I'm going to make that a midpoint. So now you can see it goes right through the middle. And then I'm going to make this guy horizontal. Make it horizontal. Then I'm going to go ahead and click it one more time. And then we're going to add for construction and infinite line. So what a construction line does is it doesn't actually add anything to the sketch, but instead it allows the sketch to be defined off of this line for different reasons. And then infinite length, so I just made it an axis. You can kind of see if I scrolled out forever, it would keep going. But what this will be used for is if we go ahead and exit the sketch, so you can either exit the sketch with these two buttons up here, or right here where it actually says exit sketch. I use this one. You can use whatever one you like. All right, so now we can see we have this sketch right here. We got rid of that little dashed line, which means everything is constrained. As well, this arrow the arrow right there means it's defined off other things. So the nice part about this is, say we were to move, say we were to move this highlighted bearing right here to the right or to the left, it would actually extend this box with it. So the nice part about that is, this is why we do assembly. This is called assembly driven CAD. And so as you change your assembly due to whatever other things like that, it'll then move this part, move your part with it. And so everything should update off of itself, which is very nice to have, but also it can be tricky at sometimes. So there's a little bit of an art to it, but once you kind of get the hang of it, it's really nice and it works a lot better, makes yourself more productive because you'll do stuff and then changes that you make later down the line, instead of having to redo everything, it just will auto update, which is pretty cool to do. So now what I'm going to do is, say you didn't have anything selected, what you could do is you could hit feature, revolve base, and it'll ask you to select something. So what I like to do is I'll just select my sketch beforehand. So now you can see it's highlighted right there. I'll go ahead and hit revolve boss base. And now you can see a preview of it. It revolves it all the way around. And so with the revolve, you see you have blind. There's different things. So maybe you want to only go up to a surface or some other stuff like that. You can do that as well. Say it was a little bit more complex, you could do direction 2. So you could have it go one way and then go the other way as well. Thin feature as well. Sometimes it's nice selected contours. So say you didn't want this whole thing, or you had like a hole in it or something like that, you could select only the parts that you want, but I want this whole thing. And as well, I want it to go 360 degrees. So that is perfect for me. And now you can see we have this nice thing right here, and that is right around it. So if we go ahead and right click it and we go change transparency, it should, oh, there we go. So now we can see we got our part right around it, and it's right over these bearings, and we got that tube, and it should be able to let the tube in. And so yeah. So we'll go right click again and just hit change transparency to make it like that. So yeah, awesome. So now what we're gonna do is we're gonna make those tubes that now connect from this guy up to here. So what I'm going to do now is, or I guess, does anyone have any questions as of right now? I feel like that should have covered most of the basic stuff. So I think now would be a good time if you had any questions.
Yeah, I just think we should wrap up soon. The time was till 2.
Oh, it was until 2? Oh, sorry about that.
Yeah,
I thought
no,
it was
it's all
till
good.
2:30. Yeah, but I hope that gave you a good, I guess, idea. Oh, I think no one else is in here. Okay, never mind.
Do you have any last remarks before we stop the recording?
I love formula.
Formula gang, let's go.